Good morning, Pirates. Now that you know how to balance equations and identify the type of reaction, we're going to focus on how to predict the products. And just a reminder, in a chemical reaction, the reactants are what you begin with, like the ingredients in a recipe. And the products we're focusing on are here on the right side of the arrow after the yield sign. Okay, so let's take each of our 5 main types of reactions and figure out how to predict products. In a synthesis reaction, 2 or more substances are on the reactant side. And remember, you identify it being a synthesis reaction because there's only one product. To identify that product, you are basically going to write a compound that contains both of the individual elements on the left side of the reaction. However, you need to write their charges and crisscross like we did first semester. So in this reaction, when sodium and chlorine are added together, we know the final product will have sodium and chlorine in that final compound. We need to look at the charges and balance them out to figure out the correct formula. Remember, on this side, chlorine has a 2 after it because it's one of our 7 diatomic elements. That's only when it's by itself. When it's in a compound, we have to look at the charges. If we look at sodium and trace up, it has a +1 charge. And if we look at chlorine on the right side, it has a -1 charge because it needs to gain 1 electron to become stable. So if we have a +1 and -1, we know that those add up to 0. Or if you like the crisscross method, our final formula will be NaCl. So once again, you write the charges of both ions from the left side of the reaction, and then you crisscross those charges. So this is our final answer. However, you would focus on balancing it next. Okay, in a decomposition reaction, we know that what identifies it here is you have one single reactant. It's the opposite of synthesis where you had one final product on the right side of the arrow. This time here, you have one reactant on the left side of the arrow. And it's broken down into 2 or more products, okay? For the ones that we're going to be giving you, you could just take the initial compound and break it down into its individual components or its individual elements. So for example, KCl has potassium and chlorine in this compound. So it's going to break down into potassium by itself and chlorine by itself. However, remember, Hunkelbrief, hydrogen, oxygen, nitrogen, chlorine, bromine, iodide, and fluorine are the 7 elements that when they're by themselves, when they're not in a compound, just alone on their own, they exist in 2 atoms to be stable. So chlorine is one of those. So we have to write Cl2. All the other elements on the periodic table would just be its individual letter or 2 letters combined without any subscripts. Then, of course, you would balance the reaction. Okay. 2 or last 3 that are a little bit more complicated. In a single replacement reaction, we know atoms of one element is going to replace an element from the compound that it's added to. It's always an element plus a compound. Okay? The key thing to keep in mind, though, is like replaces like. So, for example, if element A by itself is a metal or a cation, it would replace the cation in this compound, which is why if they switch places, you now see A is with C and B is by itself. Okay? So the cation would replace the cation if the cation is by itself, or the anion or nonmetal would replace the other nonmetal if it's by itself. So here's what you remember from the last lecture. Look at the element by itself and identify it as a metal or a nonmetal. So zinc, if we look on the periodic table, is right here, element number 30. And since it is to the left side of the zigzag line, it is a metal, even though it's in the transition metal area. So zinc is a metal. It's treated like the cation. We have to figure out who it's going to replace here in hydrogen chloride. Okay, HCl, or sorry, hydrogen monochloride. Okay, which is actually hydrochloric acid. So hydrogen and chlorine technically are both nonmetals. Remember, hydrogen really should be on the right side of the periodic table. Okay. However, when hydrogen's listed first, we treat it like the cation. So zinc is going to replace hydrogen in this case. So now zinc is going to be with chlorine. And we always write the cation first, except we have to look at the charges in just a moment. And then hydrogen is going to be by itself. Okay, remember, hydrogen, though, is one of our diatomics. So hydrogen by itself has an H2, even though over here it did not, because here, when you balance out the charges, we only needed one hydrogen atom. Okay, and that's where balancing the equations at the end with coefficients will come into play. So now to write zinc and chlorine, we look at the charges on the periodic table. You might remember silver and zinc are the ones you have to memorize. Zinc is always +2, silver is always +1. So zinc +2. Chlorine, we just looked at in the last problem, has a -1 charge. So if we were to crisscross these, we get ZnCl2 for our new compound that is formed, plus hydrogen. And then, of course, you would balance it. All right, with our fourth type of reaction with double replacement, okay, like replaces like, okay? Some of you might also do outies and innies, so I'll show you both, okay? So in the first example, the two positive cations are going to replace each other. So the cations are always listed first. So A and C are going to switch places. And if they do that, now you'll see that A is going to be in a compound with D, and C is now in a compound with B. Except make sure you always write the cation first in both new compounds. Okay. The other way some people like to look at it is outies and innies. I'm not talking belly buttons. So the outer elements are going to form a new substance, A and D, and B and C, the inner, or innies, will form a new substance. You just have to remember to write C first because, once again, it is the cation. So let's look at this first example that I gave you here. Lead 2 nitrate plus potassium iodide. Okay, lead is listed first, potassium's listed first. So those two are going to switch places. Okay, or you can look at outers. So lead and iodide are now going to form a new substance, and we're going to put lead first because it is the metal, or the cation. The innies, or inner, is going to be this whole nitrate anion plus this potassium. However, we always put the cation first, so the K is going to go first. Now you can see, most importantly, we have to look at the charges and crisscross. So we go to our periodic table, and we find out that lead is number 82. It's one of our transition metals, which means it can have a number of different charges. So we're going to have to find lead by looking at the charge of nitrate. So if we find nitrate on our polyatomic list, NO3 -1. So I'm going to write this down here. If NO3 was -1, and there was 2 of them because of the 2 here, and there was only 1 lead, the only way to balance out the -2 charge is if lead had a +2 charge. So you're going to have lead +2 and nitrate -1. So lead is going to keep that +2 charge here on the right side or product side. Iodide, we can look on our periodic table. Iodide's one of our halogens. It's a -1 charge, or it forms a -1 charge. So now when you crisscross those, we get lead 1, or 1 lead atom and 2 iodides. Now we move on to potassium and nitrate. Potassium is here in the first column. K forms a +1 charge. And nitrate we already looked at on the left side. So you could look on your ion list, or you could just remember that we've already done that. So +1 -1, they cancel to just KNO3. And don't forget this 3. It's part of that nitrate polyatomic ion. You can't change its name or formulas. So our two products would be lead 2 iodide, listed as you see here, PbI2 plus KNO3. And then you would write, then you would balance the equations. All right. Probably one of the easiest types of reactions is combustion. You're always going to have some sort of hydrocarbon, and a hydrocarbon looks like this compound here on the left here, okay? A hydrocarbon could have just carbon and hydrogen with any proportion. That's what the X and the Y's are. It could be CH1, CH4, C2H6, right? The X and Y could be anything. Or a hydrocarbon could also have an oxygen in it. So CHO, C6H12O6. It could be any combination of carbons, hydrogens, and oxygens. And then added to that is O2, because oxygen by itself is one of the diatomics. If you see these two reactants, the products are always going to be carbon dioxide and water. So when I gave you this example right here, automatically if you see a hydrocarbon, carbons and hydrogens, and maybe oxygens, added to O2, immediately you write your final products are carbon dioxide and water. And no, it would not matter in any of these problems the order of the products. So if you listed these as water plus carbon dioxide, that would be fine. Up here, if you listed the products as potassium nitrate plus lead 2 iodide, that would be fine. It does not matter the order of the reactants or the products. I hope that helped you identify the types of products. Have a great day. Go Pirates.